Our aim is simply design an algorithm that will perform the product operation but without using the multiplication operator. So I'm just using the addition operator. Okay, so let's see the first version. I'm using a variable p, let's say, to store the product result. So initially p is assigned value 0. Then I'm using a for loop. I'm having two integers m and n. Okay, so I'm using a for loop that will limit till m. Okay, and now I will perform the repeated addition. So here for I is equals to 1 to m, I'm using as a limits of my for loop, and then I'm doing p is equals to p plus n. Okay, so m times I'm adding p plus n. Okay, so this operation I'm doing. So whether it is going to give me the product, the required product, because product is nothing but the repeated operation. Okay, so if I'm writing this instruction, this will give me the product of m and n, right? Am I correct?
Yes, ma'am.
Okay,
Correct.
fine. So this is version 1 where I'm using the limit of m with for loop. Okay, in second version I'm using the limit of n now. Okay, so for I is equal to 1 to n, I'm doing p is equals to p plus m now. Okay, so this is the difference over here. So I'm simply limiting with the for loops, and the whatever instruction that is there inside, accordingly I'm changing. In one algorithm I'm doing p plus n for m times, and another one p plus m n times. So let's now check what will be the complexity of these two algorithms with example. So let's say suppose m is equals to 12 and n is equals to 6. Okay, so as per the version 1, p is equals to p plus n will be executed 12 times because my limit of for loop is m. Okay, so 12 times the version 1 will execute it, and version 2 will be p is equals to p plus m. This instruction will be executed 6 times because my n limits are there, and that is 6. Okay, so if I draw a graph for that, then against time and version. So for the first algorithm, 12 times instruction is getting executed. For version 2, 6 times execution of instruction is there. So this is the trade-off between the savings with respect to the time. Okay, right? And again, this totally depends on which value is greater and which value is smaller, right? Okay, so accordingly you can just design the limits of your for loops. So deciding the limits of for loops plays a major role while devising the steps for algorithm. Okay, so this is how everything that you are going to choose, like the design system, the design pattern that you are going to follow, it largely affects on the running time of an algorithm on a system. So you should always focus on what are the data structures required, what are the arithmetic operations that are required, and what are the limits that you are going to specify. So this was a simple example. Okay, so these concepts are nothing but these are called as a priori analysis and a posteriori analysis. So this is nothing but whenever you are doing the analysis before execution of the algorithm on a machine, that is called as a priori analysis, and testing an algorithm practically by executing the code on a machine is called as a posteriori analysis.